The International Space Station, a monument to human ingenuity. The International Space Station (ISS) is a large, habitable artificial satellite and a permanently crewed laboratory that revolves around the Earth. It is the most complex international scientific and engineering project in history, and the largest structure humans have ever placed in space. Let's dive into some fascinating facts about the ISS international collaboration. The ISS program is a joint project between 5 participating space agencies: NASA, United States; Roscosmos, Russia; JSC, Japan; ESA, Europe; and CSA, Canada. Its ownership and use are established by intergovernmental treaties and agreements, with more than 15 countries involved in its management and operation, orbit and movement. The ISS orbits Earth at an altitude of approximately 400 kilometers above the Earth's surface, ranging from 278 to 460 kilometers. It circles the globe every 90 to 92 minutes at a speed of about 28,000 kilometers per hour, or 7.66 kilometers per second, completing 15.5 to 16 orbits per day. Its orbit extends from 52 degrees north latitude to 52 degrees south latitude. What is a low Earth orbit? Satellites in low Earth orbit (LEO), including the ISS, are found relatively close to Earth's surface. These orbits typically range from a few hundred to a few thousand kilometers above the Earth's surface, because they're closer to Earth. Satellites in LEO require less energy to reach their orbit compared to satellites in higher orbits. The lower orbit means that the ISS experiences a relatively faster speed to maintain its position. Purpose and activities: the ISS serves as a crucial platform for conducting microgravity and space environment research. Here, crew members carry out experiments in various fields, including combustion science, materials science, biology, human biology, physics, astronomy, meteorology, and geology. By studying these phenomena in microgravity, scientists gain insights into how they differ from their counterparts on Earth. For instance, protein crystals grown in space can attain larger sizes and higher quality, making them ideal for medical research. The ISS also provides a unique environment for testing spacecraft systems that are necessary for future missions to the Moon and Mars. Experiments on the ISS involve observing combustion characteristics, including flame extinction, combustion instability, and soot production, shedding light on how fires behave in space. Materials science experiments on the ISS examine how fluids and materials behave differently in microgravity, offering valuable data for researchers. Additionally, biological research on the ISS investigates the effects of space conditions on various biological specimens, advancing our understanding of life in space. Astronomers also utilize the ISS as a vantage point to observe the universe. Without the distortion caused by Earth's atmosphere, allowing them to study celestial objects and phenomena with greater clarity. The ISS enables continuous observation of the dynamic relationship between Earth and the Sun, providing insights into solar activity and its influence on Earth. History and decommissioning. The first component of the ISS was launched into orbit in November 1998. Since then, it has been continuously inhabited by an international crew since May 2001. The ISS is currently scheduled to remain operational until at least 2030, after which it will be decommissioned. Several private companies are actively developing commercial space stations to succeed the ISS. Notable missions and events. Space tourists. In 2001, Dennis Tito became the first space tourist spending a week on the ISS after reaching it via a Russian Soyuz rocket. He paid nearly $20 million for the trip. Crew Dragon and Boeing Starliner, SpaceX's Crew Dragon spacecraft, developed under NASA's Commercial Crew Program, has successfully transported astronauts to the ISS. This marks the first time a private company has flown astronauts for human spaceflight. Boeing is also working on the Starliner spacecraft designed to transport astronauts to the ISS. Russian contributions. Roscosmos, the Russian space agency, provides modules that are responsible for course corrections, keeping the ISS away from space debris and ferrying astronauts using Soyuz rockets. In July 2021, Roscosmos launched the Nauka module, Russia's biggest space laboratory, to the ISS. Indian astronauts and Gaganyaan mission. India and the US envision a joint ISRO-NASA effort to the ISS. The Human Spaceflight Center (HSFC) of ISRO has signed an agreement with Axiom Space, Inc. for India's participation in the Axiom 4 mission to International Space Station. At India's future space station Bharatiya Antariksh station bus. ISRO plans to develop and launch its own space station, the Bharatiya Antariksh station, by 2035. The first module, BAS-1, is expected by 2028. The bus will be smaller than the ISS, weighing around 22-52 tons, and will orbit at an altitude of 400-450 kilometers. It will be used for microgravity experiments and will accommodate astronauts for up to 20 days. The space docking experiment SPADOX is a crucial technology being developed by ISRO for the bus, which will enable assembling large structures and transferring crew or supplies in space. India achieved another milestone in its space program on January 16, 2025. When 2 SPADOX satellites successfully docked, making India the 4th country after the US, Russia, and China to achieve this feat. The European Space Agency (ESA) is also considering future possibilities for sending an astronaut to India's planned bus. Environment on the ISS. Astronauts aboard the ISS experience microgravity conditions, which necessitates specific adaptations to daily life. Consuming dehydrated food and exercising regularly are essential to prevent muscle atrophy and other health issues. Extended isolation and microgravity can also have psychological effects on the astronauts. The continuous presence of humans on the ISS since 2000 makes it the longest. Continuous human presence in low Earth orbit. The ISS stands as a testament to international cooperation, scientific exploration, and human resilience. As we continue to push the boundaries of space exploration, the knowledge and experiences gained from the ISS will pave the way for future endeavors, inspiring generations to come.